Okay, so a couple of announcements. We are quickly nearing the end of our semester, which is kind of exciting. Christmas break is coming. We are excited. Okay, so we are currently in week 15. You will soon see week 16 come up. Now, we have 2 exams left. Okay, so I'm going to write that right here. Okay, so we have the week 16 exam and the final exam. Okay, now, if you need to take the week 16 and the final exam at home, there is no max grade. Whatever you get on the exam, that's what goes into the course. Okay, for the others, there's a max grade, and I recommend you come in and redo any of exams 1, 2, or 3. Yeah. If you have a max grade, redo them for full credit. And once you come in to redo them, you might realize, wow, it's just simple taking the exam in person. When you take the exam online, you have to make a video, there's free response, there's Canvas problems. It's just more stuff. Okay, highly recommend you come in. So this is week 16 and week 17 is the final exam. No max grade, but we have 2 exams left. Okay, so that is the scoop. Okay, so without further ado, let's get started. Find the interior angle sum for a polygon. Okay, let's start with a simple polygon. What is the sum of the interior angles of a triangle? Does anyone remember? Ding, 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 180. Okay, how about a rectangle? Yeah, what is the sum of the interior angles? All right, so that is going to be 360. Okay, so 180 for a triangle, 360 for a rectangle. Now look at this. If I take my rectangle, I'm going to get rid of these. I could divide it. Now, notice I have the top, which would give me 180. You with me? And the bottom, which would give me 180. And I'm going to sneeze. Excuse me. I've never had a sneeze on a video before. Okay. Now, can you see where we get the 360? You knew it was 360 because it has 4 right angles. But we could also see that a rectangle could be divided into 2 triangles, each triangle having the interior angle sum of 180 degrees. Are you with me? Can I get a thumbs up? Yeah. Yay. Oh, thank you. Bless your heart. You typed in thumbs up. I think there's a way to do it. I don't really know how from your end. But there's like these little things, Zoom things. Okay, anyway, I'm not usually on your end. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have an 11 gone. Oh, yay, cute, thank you. Okay, we have an 11 gone. So 11 sides. So the variable assigned to how many sides there are is n. Okay, so we have an 11 gone. So visually, this is what it looks like. Pick a vertex. Okay, so pick a vertex and draw lines to every other vertex. So be better with a ruler. Kind of looks like a shell. Okay, so we have n equals 11, 11 sides. Notice I did not draw there because that would just look like this, right? That doesn't make a triangle, and I did not draw there. There's two of them I lost. Okay, so the question is, how many triangles? Okay, when there's 11 sides, so let's count them. 9 triangles. Yeah, do you see that when I had 11 sides, I didn't get 11 triangles. I got 9 triangles. And what do we know about the sum of the measures of the interior angles of each triangle? Each one is, yeah, they are 180. Okay, so I'm going to take 9 times 180, which will give me 1,620. Okay, now if we met every day, we would do a bunch of these and we would discover the formula. But I'm just going to tell you the formula. Okay, so the formula is n minus 2 times 180. Yeah, n minus 2 times 180, which makes sense. 11 sides, 9 triangles. We saw the pattern in one example. Just trust me, it happens in all of them. Okay, so you have 2 fewer triangles than sides. Okay, n is 11. So we would take 11 minus 2 is 9 times 180. That gives you the sum of the interior angles of a polygon. Okay, so an interior angle. This is the interior angle. So the sum of the interior angles of a polygon. Okay, when you add all of them up, you get 1,620. So that is an interior angle. Then what is an exterior angle? Okay, so we're going to zoom over here. Zoom. Okay, so the exterior angle is supplementary to the interior angle. Yeah, so you take one of the sides and you draw a line. So they are supplementary. So now let's say this is an equilateral triangle. Doesn't look equilateral, the bottom looks too big. Let's just pretend this is an equilateral triangle. So let's go around and make the 3 exterior angles. It's hard for me. That looks horrible. Now, there's a video or something, I can't remember, where it talks about you're facing this direction, and then you face this direction, and then you face this direction, and then you face this direction again. Can you see that you're going all the way around a circle? The exterior angles are like turn to your left, turn to your left, turn to left, bang, you're back where you started. Okay, which would be so fun if you guys were here in person, we could actually stand up and do that, but we're not. Okay. Now, if this is an equilateral triangle with numbers that work out really nice, this is 60, 60, 60. Yeah, are you with me? All right. Assuming you're with me. Yeah. All right. Got a yeah. Okay. If the exterior angle is supplementary to the interior angle, then that leaves 120 on all of these. Okay, so now what would the sum of the exterior angles of an equilateral triangle be? We have three 120s, which is 360. Huh. Well, that's kind of, yeah, there we go. Thank you. That's kind of interesting because it's like you start off facing this direction, turn to the left, turn to the left, turn to the left. It's kind of like the exterior ones make a complete circle. Yeah. But anyway, mathematically, I got 360 degrees. Okay. Now, notice, now let's try a rectangle. We could have done a square, but we're going to try a rectangle. So we know the sum of the interior is 360. Now let's talk about the exterior. Okay. Okay. Hold on one sec. Okay, little conversation out there that does not need to be on my video. Okay, so let's talk about the exterior angles. Yeah. So the exterior angle is supplementary to the interior angle. Yeah. Okay. So look, face the right, turn to the left, turn to the left, turn to the left, turn again. Oh, you're facing the right again. Interesting. Okay. So what is the sum of the exterior angles? So if they're supplementary, these are also 90. Yeah, do we see why those are 90? So I have four 90s, which is 360. Oh, there you go. Nice. Okay, you're ahead of me. Now, I do not want you to focus on the fact that the interior and the exterior were 360. That's a fluke. Okay, but I want you to notice that for the triangle and for the three-sided figure and the four-sided figure, we got 360. So now what if I wanted the exterior angles of this 11 gone? Let's take a look at this. Do you see how the bigger the sides, the smaller it's going to get? Now, if it's 1620, okay, don't worry about this right now. This is just for your enjoyment. Divide it by 11. Each one is 1620 divided by 11. Each one is 147.27. 272727. Yeah, that means the exterior angle is 39.27. Oh, you know what? I think I missed a 7 right there. Okay, 272727. Okay, are you ready for something magical? Okay, so, uh-oh. This is actually really cool. This is the proof. Sometimes it's good to prove something. So I had 1620. Are you looking at my calculator? Divided by 11. Okay, there's one interior angle, right? The interior angles are the big ones. I'm going to subtract from 180. Okay, and then change the sign because, okay. Does everyone see that one exterior angle is 32.7? Oh, okay, so I was wrong. There is no 2 right there. And there's no 7 right there. Okay. Bring back the calculator. Okay, does everyone see that 39.72 is the measure of an exterior angle of this 11 gone? So that's one exterior angle. I'm going to multiply it by 11. And does anyone have a guess how much it's going to be when I have 11? Oh, what the heck? Better make sure this is going to work out. Wow, I was like off here. Why did I put 9 when it's 2? Okay. So I took the total, I divided it by 11 because there's 11 sides. I didn't plan to do this. This should be really cool. When I hit enter, 11 of these is dun, 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 360. Okay, so all that craziness, you don't have to do all that. But do you guys believe me when I say the sum of the exterior angles equals 360 always, no matter how many sides? The sum of the exterior angles equals 360. That was my whole point. It was a little messy, but does that make sense? Whether it is 3-sided, 4-sided, or 11-sided, the sum of the exterior angles is 360. We need to move on because we're now on number 2. Okay, so this is regular. If it's regular, then they're all equal to each other. If it's not regular, then they're not all going to be equal to each other, but it says it's regular. So how can we find the measure of one interior angle? Oh, this is an 11 gone. Oops, sorry. One exterior angle, draw a line, supplementary. We're going to take 360 and we're going to divide it by n. 360 divided by 11, 32.72. Round to the nearest tenth, 32.7. Okay, so this is going to be super easy. You're just going to take for one exterior angle, you're going to take 360, you're going to divide it by n. So that's it. Yes, total for that one. Okay, next. If this is a trapezoid, solve for x. Okay, if it is a trapezoid. So what do we know about corresponding? No, sorry. They're called consecutive interior angles of a trapezoid. Now, disclaimer, they have to be on opposite parallel sides. All right. You guys are like, hurry up. Okay, we know that when we talked about these are parallel, right? It's a trapezoid. So we talked about same side interior. Okay, are supplementary. So 11x plus 125 is equal to, and you're already telling me, 180. Yeah, can you see that we have an obtuse angle, an acute angle? Yeah, don't be telling me that those are equal to each other. One's big and one's small. They are supplementary. Okay, now we solve. Subtract 125. 11x is equal to 55. Divide by 11. X equals 5. Oh, thank you. Isolate. Correct. Okay, next. Okay, find the measure of one interior angle of a polygon. And it is regular because that's important. Otherwise, they'd have the same sum, but each one would be different. So interior angle. What is the formula for the interior angle? The sum of the interior angles is n minus 2 times 180, correct? So what is n? 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9. So we're going to take 9 minus 2 times 180. Please excuse my dear Aunt Sally. We're going to do parentheses times 180. And we are going to get oh, what? 7 times 180. I did. You guys, so sorry. I trusted my notes. 9 times 180. Is that right? 9 times 180. What? Okay, you guys, I am kind of tripping here. So 7 times 180. Oh my goodness, you guys. So I may have a little bit of dyslexia. 1, 2, 6, 0. Okay, I was looking at number 1. This is really weird, and I've never noticed it before, and I kept thinking I did it wrong. Notice 1, 2, 6, 0. And this one is 1620. I thought, like, I was thinking they're the same number. Okay, guys, I'm so sorry. And this is on the video of me tripping out like this. Okay, I am so sorry. 1260. You're like, move on. Divide by. Okay, so one angle, correct. 1260. Divide by 7 or divide by 9? Ah, divide by 9, right? Is 140. So each one is 140 because it's regular, so they're all the same. Okay, moving on. Okay. Solve for x. Okay, yeah. Do you see how tempting that is to divide by 7? Yeah, but if you divided by 7, you'd get back to 180. Okay, super important. And let me tell you, I see a lot of people right here, they want to divide by 7. Yeah, divide by 9. Okay. This is a parallelogram. And I don't like writing the word parallelogram. It's way too many letters. So I just put that. So if it is a parallelogram, then opposite angles are what? If it's a parallelogram, opposite angles, ooh, not corresponding, because corresponding would look like this. Yeah. So, and they're not consecutive. These are opposite angles, but good guess, are congruent to each other. Yeah. Consecutive are supplementary, but opposite are congruent. So 41x plus 1 is equal to 42. Yeah, now we're going to solve. Subtract 1. 41x is equal to 41. And divide. X is equal to 1. Okay, opposite angles are congruent. Okay, so notice you got to think. Everyone is different. Okay, is this a trapezoid? I don't know. It doesn't say it's a trapezoid. The only thing we know is it's a quadrilateral. So how can we find the missing angle? Any thoughts? Ding, ding, ding. Okay, so n equals 4. So let's find the sum of the interior angles. So we're going to go n minus 2 times 180, which is 4 minus 2 times 180, which is 2 times 180, which is 360. So an irregular quadrilateral is 360, just like the rectangle was. Yeah, because n equals 4. Anytime you get n equals 4. Okay, so x plus 66 plus 106 is equal to 360. Is this correct? Or did I miss something? Yeah, I missed the 90, huh? Okay, x 66, 106, 90 equals 360. Welcome. Okay, add the like terms. X plus 262 is equal to 360. minus 262. X is equal to 98, which looks right. It's just a little bigger than a 90-degree angle. But looks can be deceiving, but yeah, it looks right. Okay, next. Okay, so we're going to solve and justify. Okay, if it's a parallelogram, then opposite. Okay, what are we talking about here? Those are sides or angles? Sides. Opposite sides are congruent. So 5x minus 2 is equal to 18. Isolate your variable, add 2 to both sides. 5x is equal to 20. Divide by 5. X is equal to 4. Okay, number 8. We also have opposite sides. This is on your own, or you can request it at the end. Number 9. Okay, the interior sum is 1440. How many sides? Now, what variable do we usually assign to how many sides? What letter? What are we looking for? We're solving for what letter? All right, N. It looks like hamburger N. Okay, so we're solving for N. So the formula for the interior angle sum is N minus 2 times 180 is equal to 1440. Now, I like to put the 180 in the beginning because that's how I'm comfortable distributing. I'm going to erase this. Okay, so there are 2 options in solving this equation. I can either distribute or divide before distributing. So we're going to do the shortcut. We are going to, so if I had like a +3 here, it wouldn't work. But since both of those numbers are about to have a 180 multiplied, I can do a shortcut and divide. So everything on the left got divided by 180. Nothing got left out. N minus 2 is equal to 8. And then the last step, add 2. N is equal to 10. Okay, so now we're going to review a little bit. Number 10, review. Let's make a flowchart proof. Okay. It says add letters. I added the letters for you. Now, what is the given? There are 2 givens here. And it's not stated. What is one given? Right here? So we're going to say AC congruent to ED. D. Can you see that's given? Usually it would be up here. And correct, angle C congruent to angle D. Okay. Therefore, oh, and there's one more piece. What is the missing piece that we haven't said yet? Almost. First, we have to say, now, can I say angle B congruent to angle B? No, I cannot. Because if I say angle B, is it this one or is it this one? So I'm going to use 3 letters. Angle ACB. No. Angle right here. ABC is congruent to angle EBD. Okay, so why are these angles congruent? Or vertical angles are congruent. Okay. Now, what is it? Triangle ABC congruent to triangle. So A corresponds with E. EBD, because, so I have 2 angles and I have one side. Does the side touch one angle or both angles? It only touches one, right? So angle, side. Okay, this one you can cross off. Do not do. If you want to see it, it's on last year's video, or you can request it on the end, but you do not have to do number 11. Number 12, state the most specific name. Now we know it's a quadrilateral. Do we know anything else? Is it a parallelogram? No, because opposite sides are not parallel. Oh, 2 pairs of sides are congruent. So I have 2 pairs of consecutive sides congruent. So basically, if I turned it, looks like that. Ding, ding, ding. This is a kite. Okay, it's not a parallelogram. 2 pairs of consecutive sides are congruent. Okay, how about this one? I have a quadrilateral and I have 1 pair of opposite sides parallel. Ding, 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 trapezoid. Okay. Okay, I know this is a quadrilateral. I see that it has 4 congruent sides and 4 right angles. So 4 congruent sides. Anything, a quadrilateral with 4 congruent sides is a rhombus. 4 right angles is a rectangle. Now, what is it if it has 4 congruent sides and 4 right angles? One of those is right. It is a square. Okay, now you're thinking, I can look at that and tell it's a square. But this is the proof. If it has 4 congruent sides, it's a rhombus. If it has 4 right angles, it's a rectangle. If it has both, it's a square. Okay, it has to have 4 congruent sides and 4 right angles. Next, and you guys are great participating. Okay, it's a quadrilateral. It has 4 right angles and both pair of opposite sides are congruent. Not 4 congruent sides, just opposite sides congruent. This is a rectangle. It's not a square because square would have 4 congruent sides. I think we're good on that one because you learned that one like in 3rd grade. Okay, it's a quadrilateral with 4 congruent sides. It is a parallelogram, but it is more specific. Okay, what is the most specific name? Is rhombus. Yeah, 4 congruent sides, rhombus. Okay, next. I don't see anything congruent and I don't see anything parallel. What do we call it? Quadrilateral. All right. Oh. Next. What is the most specific? This is a trapezoid. Now, what do you notice about this trapezoid? Is there anything special about this trapezoid? Ah, it's an isosceles trapezoid. Yeah. Okay, and one more. What's this? Quad. Does it kind of look like a kite? Yeah, but we don't have any markings, so it's just a quadrilateral. Okay. Sorry, don't want to make you dizzy. Consecutive angles. What do we know? And this is a parallelogram. It's not marked, but it says so in the directions. So what do we know about consecutive angles of a parallelogram? If it's a parallelogram, then consecutive angles are anyone? Ooh, not congruent. What are they? It's the same thing as same side interior angles are supplementary. So 17x plus 9 plus 52 is equal to 180. Combine like terms, 17x plus 61 is equal to 180. Ah, interesting. Okay, so 180 minus 61 is 119. 17x is equal to 119. Divide by 17. X is equal to 7. Okay, we're going to go to 22, and then we're going to do 21. If it's a parallelogram, then these are not consecutive angles. What are these? These are opposite angles. Yeah, do we see the difference? Ooh, opposite. Yeah, but good try. Opposite angles. That's what we're going to use to describe these opposite angles. They're not consecutive. Like consecutive numbers are next to each other. That's what consecutive is. These are opposite angles. Opposite angles. Now, are they supplementary or congruent? Congruent. Okay, so 12x plus 4 is equal to 40. And we can see a parallelogram has big angles and small angles. And look, noticing that is going to help you remember which ones are supplementary and which ones are congruent to each other. Okay, isolate your variable. 12x is equal to 36. Divide by 12, x is equal to 3. Okay, so far, number 20, they were supplementary. Number 22, they were congruent. 21, which one is it going to be? Congruent or supplementary? Ding, 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 supplementary. If it's a parallelogram, then consecutive angles are supplementary. So supplementary 5x plus 15 plus 110 is equal to 180. Combine like terms, 5x plus 125 is equal to 180. Subtract. Isolate your variable. Five x is equal to 55. Correct. Divide by 5, x equals 11. Okay, so parallelograms, when they are consecutive, they are supplementary, just like same side interior. When they are opposite, they are congruent to each other. Sorry. Okay, gang. Any questions? Any requests? Are we good? All right. Thank you for joining me. Okay. Thank you. Bye-bye. Have a good day. Oh.